So there is this link. I put it on our main Schoology page, and I titled Calculus Reference Sheet. I just sent it to you in the chat, and those of you in person got a physical copy. So if you lose it, you can always go back and find it again. But the front side, the AP Stats, Stuff You Must Know Cold, this is all basically AB content. So we have curve sketching, we've got differentiation rules, so in the middle here we've got the chain rule, product rule, quotient rule. See if I can use my cursor. So these are all the very important rules with derivatives. We have approximation methods for integrals. That's the Riemann sums, the left and right trapezoidal Riemann sums. Now they do use some notation that we haven't talked about, so if you see some notation you're like, I've never seen that, don't focus on that. Okay? There's multiple ways to represent some of this stuff. Average value is a pretty big one. They wrote this a little differently than we did. We had the 1 over b minus a out in front of the integral instead of divide, but it's the same thing. Here's something really helpful. All the basic trig, all the basic derivatives. There's more derivatives down here as well. Some of the inverse trigs. Do remember with these inverse trigs, the only inverse ones you have to know are the sine, and maybe you want to put a little star next to this one, a sine inverse and the tangent inverse. Those are the only two that are going to be on the AP test if they appear. It's not a guarantee that they're going to be there, but they might. But the other ones we don't really need to know there for the inverse trig. Intermediate value theorem, extreme value theorem. The mean value theorem, that's a big one. I guarantee you're going to see a mean value theorem question, most likely a multiple choice and a free response part. And then the piece that we just did today in the warm-up was based off of distance, velocity, and acceleration. And that's what we're going to be reviewing here today. So the nice thing is hopefully this sheet will give you something as a quick reference guide. We did not notice these little asterisks here. We didn't talk about vectors, so you can actually cross out anything that's got a little asterisk here. That's technically a BC concept. So we didn't learn those with the idea of vectors. All right, so there should be 1, 2, 3, 4 in this box here. L'Hopital's rule, if you were in Miss Hires' class for first and second try, I don't think you guys covered L'Hopital's rule yet. So when we get to that, we're going to review it a little more, but that's a really friendly, helpful piece that will be on the AP test. So we'll talk about that maybe next week. If you flip it over to the back side, there's a lot of BC concepts here. So watch where my cursor is at home, and I want you guys to just cross out, put an X through basically the integration by parts, slope of a parametric. So these boxes, Euler's method, polar curves, cross those out. We did U substitution, so I would leave the U substitution. But then partial fractions, ratio test, cross those out. Anything that says series in it, so Taylor series, alternating series, integral tests, basically everything else except for leave the entire right column. The entire right column and U substitution. Those are the only things that you should know from AB. We didn't do anything with series at all. So anything that says series, basically this whole lower left quadrant, all of that can be crossed out. Just leave the entire right side. And look at the integrals. Don't forget plus C. Here are all of the integrals that you should know. Those are the antiderivatives. And if you have the electronic copy, for some reason this little piece on the bottom goes to the Lagrange error bound. That is a BC, so we don't need that as well. So anyways, this is just something to really be mindful of, and it might be something you want to study. You will not be able to use this on the AP test, so don't use this as like, I can only do things if I look at the sheet. All right. Okay, so I decided I might try to do this. You guys let me know if you like this better or worse. When we go over AP questions, it takes a while. And I don't know if you guys know this, but I talk a lot. So what I decided to do was try to make this a little faster, and I worked out the problems ahead of time, and I just did a screenshot of my answers so we can quick talk about it. You guys can ask questions and we can move on. But let's look at what we have here. So a particle's velocity is modeled by the equation v of t for times greater than 0. Its position at 0 is 4 seconds, or at 0 seconds is 4 meters. So notice the way they wrote this. X of 0, so x stands for our position equation. So we know that the starting position is at 4. All right, number 1, find the equation for the particle's acceleration at time t. Well, what we need to do is we need to take the derivative of velocity. The derivative of velocity is acceleration. So this is what I did. So let me go there. I'm going to have to make this bigger and smaller as we go. So here's my number 1. I took the derivative. So here's velocity. The derivative of 2t is 2. The derivative here, you have to use the chain rule. So the derivative of sine is cosine. And then notice this extra 1/3. That came from the chain rule, and they guarantee they're testing that chain rule. All right, and then just to simplify it, I took the 1/3 times the -2 and wrote it as -2/3. So there's number 1. Number 2 asked us to calculate the derivative of the velocity at pi over 3. Well, wait a minute. Derivative of velocity, isn't that acceleration? You're taking your equation that you just had in number 1, and you're going to plug in 3 pi. So I wrote derivative of velocity at 3 pi is the same as the acceleration at 3 pi. And then I just plugged in 3 pi, and we have to divide that by 3. So really, it's just cosine at pi. And what is the cosine of pi? That's -1. And then it ends up being 2 plus 2/3, which is 8/3. And then it did say interpret your answer. So if this was a true AP question, you would have to explain what you just found. Well, the derivative of velocity is the acceleration. So what did we find? The acceleration at time 3 pi seconds is 8/3 meters per second squared. And they didn't specifically ask for the units, but by interpreting, I provided the units. Let's say that this was actually a free response question, and if you got number 1 wrong, but you used your wrong answer equation in number 2 and you used it correctly, they would award you the points for number 2, which is kind of nice, because even if you make an error here, you still get the credit because you showed the knowledge. So that's the importance of doing every problem and not skipping anything. If you skip something, write something down and use that. Even if it's wrong, you might get some points. So, all right, number 3. Is the particle's acceleration increasing or decreasing? And that's, so if acceleration is increasing or decreasing, we have to check 2 things. We have to check the velocity and the acceleration. So here's what I did for number 3. I'll make this bigger and then just show you the pieces. So what I did for number 3 was I tested the acceleration at 2 pi. So I plugged in 2 pi, evaluated it using the unit circle, and then I ended up with the acceleration at 2 pi is a 7/2. Big thing is it's positive. So acceleration is positive. And then I checked the velocity at 2 pi, and I found that the velocity is also positive. Now, how do I know this is positive? Well, 4 times pi is going to be larger than 12. The square root of 3 is smaller than 12. So I know that this answer is positive. Now look at my explanation here. Since v of 2 pi is positive, it's greater than 0, and a of 2 pi, so acceleration at 2 pi is positive, the acceleration is increasing at time 2 pi. How do I know? The acceleration and the velocity have the same signs. So when forces are acting together, we're speeding up, we're going faster, we're increasing our acceleration. If the velocity was a different sign than the acceleration, those forces are acting upon each other, and that's friction, and that slows things down. Right? So we'll talk about that. That's part of the review today, is just referring to when a function is increasing or decreasing, you got to check the signs of both acceleration and velocity. Now I will post all of this on Schoology, so if you ever need to go back and look at it, you will. So that way, I know you're trying to make some notes as well. Number 4, what is the position of the particle at time of pi? Well, they gave us the velocity. Now they're asking us a question about the position. So we're going backwards, which should tell you there's an antiderivative or an integral. So here's how I did number 4. Let me make this bigger so you can actually see it. So position at time pi seconds is, remember the notation, they said x of t was position. So to figure out what that is, I have to take my start. And in the directions, they said at time 0, the position was 4. So I have my start plus the integral from 0 to pi of velocity. We basically did a question like this yesterday. Remember the setup? It was the start plus the accumulation. And that's what we're doing, is we're accumulating the velocity to figure out our position. Now, this is a u substitution problem, because to find the antiderivative, this t over 3 is causing me a problem. So I did u substitution, took the derivative, and noticed that there was a 1/3 that was not accounted for. So I had to bring that over, and that's how this -2 turned into a 6. Is I have a 3, I didn't show that step, but 3 times 2 is 6. And the antiderivative of negative sign is a negative cosine, so a negative and a negative turned that into a positive. So then we found the antiderivative. We're going to plug in pi and 0. And remember how we said you could just stop at a certain point? Right here, I believe they would accept that. They might ask you to do the trig function, so cosine at pi over 3 is 1/2. But again, you could stop for sure, definitely right here. I just simplified further, and I ended up getting that the position at pi was 1 plus pi squared meters. And that's as far as we can go, right? We don't have a calculator, so pi squared, we don't want to pretend that we're going to multiply out pi and square it. So just leave it. All right, so big takeaway from number 4 is if they give you velocity, they gave us the velocity equation, and they ask me to do position, I have to undo that with the antiderivative of the integral. All right, and then question 5 was, they asked us, what was 5 asking? Is the particle speed increasing or decreasing at pi? This is kind of the same thing as the acceleration. If I'm going to check to see if a speed is increasing, I need to check to see that the velocity and the acceleration are the same sign at that spot. So what I did was I took velocity at pi, evaluated it using the unit circle, and I found out that 2 pi minus the square root of 3, even though I didn't have a calculator, I knew that that was greater than 0. So we know that the velocity is positive at pi, and if we did the same thing for our acceleration equation, we end up getting the fact that acceleration is positive as well. So since both the velocity and the acceleration are positive, the speed would be increasing at time pi seconds. Okay. Now notice my justification here. It's kind of sloppy, but it just says v of pi is greater than 0, a of pi is greater than 0. That says both signs are positive. Okay. Would you guys prefer this? Okay. Otherwise it gets long, and if you know it, then it's great. If not, I mean, my goal is to do what's best for you, so I'm not sure if some people like that or not. All right. So what we're going to do then is we're going to look at a couple different problems. The rest of them are multiple choice today. Some of them are no calculator, and some are calculator. I have this just as a review, just to quickly talk about. By no means should you write this down. But our goal today is to look at particular motion or particle motion free response questions, just like you kind of experienced. This includes talking about speed. So one of the many concepts related to motion problems are the same as those related to function or graph analysis. So remember when we were looking at a graph and we tell you to find a max or a min, is it increasing or decreasing, and it's all based off of the derivative? Same thing with particle motion, except for there's context. So they tell us to stress the similarities and show students how the same concepts go by different names. For example, when finding a particle that is farthest to the right, that's the same thing as finding the absolute maximum. So if it says when is a particle furthest to the left or furthest to the right, you're thinking absolute max or absolute min. Anytime you go to the right, it's a maximum. Anytime you go to the left, that's a minimum. These values are usually one free response question and then some multiple choice. So big things to take away. Remember, position is just your s of t or x of t. And how's that related? Well, if I know the position, the velocity is just the derivative. Speed is the absolute value of velocity. Acceleration is the derivative of velocity, or the second derivative of position. Velocity is the antiderivative of acceleration. So if I know acceleration, I can undo it using the integral to get velocity. And position is the antiderivative of velocity. So it's that chain of events, how things are all mixed together. Okay. This you have on your sheet, which is why we don't need to write any of this down. Some big takeaways. Remember, if we asked you to find the total distance, it's just adding all the values, positive and negative, and adding them together. So how far did you travel total? All that is the integral from the start to the end of the absolute value of v. Okay? And then total distance is defined by the integral of speed, which that's what speed is right here. Be sure that we understand the difference between total distance and displacement. Look at the difference here. Total distance had the absolute value. That turned all the areas positive. Displacement is just saying what's the area under the curve. If it's below the curve, it's negative. If it's above the curve, it's positive. And it's just where are you at the end of the time. Right? So if I walk to the left 3 units and then I walk to the right 10 units, my displacement would be 7. 7 units away from where I started. Notice here, if I know the displacement, all I'm going to do is take that and add my starting spot, and that will give me my final position. So let's say that I was on a football field, and I started at the 50-yard line. Well, I would put plus 50, and then if I went 10 yards to the right and 20 yards to the left, I would be negative 10 yards plus 50. That would put me at the 40-yard line. Speed is to find the speed at a given time. It's just the absolute value of velocity. We mentioned that a couple of times. Average speed. This is interesting. So if I ask you to find the average speed or average velocity or average acceleration, it's just slope, right? Your change in y's over change in x's. That's going to come up here, and we'll talk about it in a second. This is the big one that they usually have a question on it, and we just saw that in today's warm-up twice. For speed to be increasing, the velocity and acceleration have to work together. They have to have the same sign, both positive or both negative. If they do, that's called speeding up. So they could say, is the velocity speeding up or is it increasing? And you would just check that velocity and acceleration have the same sign. Likewise, for speed to be decreasing, the velocity and acceleration have to be fighting against each other. They have to have opposite signs. So if one is positive and one is negative, then the object is slowing down. And you might make a connection to physics if you're in physics and how opposite forces react, and that whole deal works. I'm not exactly sure how far they go into this with physics. All right, so let's look at a couple of problems now. Oops, shoot. Well, there's the answer. I was trying to cover it up, but I can't. So what I'd like you to look at is, let's try this example. This would be a no calculator one. An object's displacement, notice another word for displacement is just position. So here's the position function. Is the particle speeding up or slowing down at time 2? Speeding up or slowing down? Go ahead. I'm just going to highlight what I did. So notice how I rewrote the position function here. And then I took the derivative, which maybe I should have put s prime of t just to make the connection that the derivative. So the 7 goes away, the negative 1 comes down, and we take 1 away. That's where the negative 2 came from here. And then I needed to take the derivative of that to get acceleration, which is the second derivative. So I'm just going to apply the power rule again. The negative 2 comes down, and I take 1 away. So here are my derivatives for velocity and acceleration. And then I got to test those. I have to test them at x equals 2. And you can see the velocity is a negative 1/4. The acceleration at 2 is a positive 1/4. So because velocity and acceleration are different signs, I can write my conclusion. And pay attention to how that's written. The particle is slowing down, or you could say decreasing, but they use the word slowing down. So the particle is slowing down because the velocity and the acceleration are different signs. And since I showed them here, saying different signs is good enough. You could say the velocity is negative and the acceleration is positive, and that's another way to justify it. You should still get the same answer. It might look different. It just means it would simplify a little differently, but you would still get the same answer. Yeah, I don't know if you heard that on Zoom. The question was, what if we did the quotient rule here? Because technically that is a quotient. You could apply the quotient rule. It won't look exactly like this, but it'll be equivalent. All right. We're not going to do all of these just because of time, but let's read through and just talk about what we would do with a couple of these. So these are multiple choice, no calculator. You just tell me what you would do here, and maybe I'll set up the equation and then we'll stop. But a particle moves along the x-axis so that any time t, when t is greater than 0, the acceleration is given here. So we know acceleration. If the velocity of the particle at time 0 is v of 0 is 7, and the position t of 0 is 0, then the position at time t is what? So they're asking me to find the position equation, and I know the acceleration with given points. What are we doing here overall? Antiderivative, right? We're going to undo acceleration twice. So we're not going to set this one up all the way, but what I would do is if I want to find velocity, I'm going to take the antiderivative of the acceleration, and then I'm going to add when I do that, I'll get an answer plus c. So remember, we don't have bounds here, so I can't put bounds, but I would get a plus c, and then I have to use the point when t is 0, v of t is 7. So once I get this answer, I'll put in 7 equals something plus p, and then if there's a t in here, I'll put a 0. Remember, we solved that for c, and then we'd have to do that all over again, because then we would get our answer for velocity, and I'd have to undo the velocity to get the position. And eventually, it ends up working out to be part A. It's a lot longer process, which is, we don't have time for that, but the big piece, if you're reading this, hopefully you made the connection. If they say find position, you're undoing this rate twice. For this one, let's see. For time, when t is greater than or equal to 1, the position of the particle moves along the x-axis. So here's the position equation, p of t. At what time, in the interval from 1 to 16, is the instantaneous velocity of the particle equal to the average velocity of the particle? Ooh. That's a lot. Does that scream anything we've learned before? It's been a long time since we've done it. It's on your cheat sheet. Front side, dead center of the page. It's the mean value theorem. So, this is something you do the mean value theorem, and here's what they want us to do. How do we know it's the mean value theorem? The instantaneous velocity. Well, wait a minute, instantaneous is the derivative. So I would have to find the derivative, and that has to equal the average value of the velocity. So I'm going to take the derivative. Actually, there shouldn't be a tick mark because this is position, so we take the derivative of position, which is just velocity. And then I would have to find the position from 1 to 16. So I do 16 minus 1 over the position at 16 minus the position at 1. This is a number. If we plug in 1 and plug in 16, we get the number equals the derivative, and then you just have to solve. So, I don't know if you remember doing that. Maybe we should do that one, because the mean value theorem is pretty big. So let's do this. Let's do this one right now. What I'd like you to do is take the derivative of the position, and that's going to give us the velocity. You guys get 1/2 t to the minus 1/2. for your velocity. Remember, the square root can be rewritten as t to the 1/2, and then this is just the power rule. The 1/2 comes down, we subtract 1 up top. So that's what the red part is, 1/2, and then instead of doing t to the negative 1/2, I like to rewrite it this way, with t to the negative 1/2 is the same as the square root in the denominator. And then all we have to do is figure out, what is p of 16? You probably do this in your head. You don't have to show work for this. If I plug 16 in here, well, the square root of 16 is 4. 4 minus 2 is 2. And then if I did the same thing at 1, if I plug 1 in here, square root of 1 is 1. 1 minus 2 is negative 1. So the mean value theorem says the derivative is equal to the slope of the position between 1 and 16.
What is the formula where you divide and then when you take the derivative, you divide by +1 and then do the same?
I think it's the, are you talking like the power rule, where if I took the derivative of this, the 3 comes down, and then we take 1 away to get the 2? That's the exact same thing we did here. The only difference is instead of a 3, it was a 1/2. I think that might be what you're asking?
No, you just,
Okay. So, how do I solve this? Sometimes we get kids who are at the spot here, and then they kind of melt down. It's like, oh man, how do I solve this? Well, let's just simplify really quick. So we get 2 minus a negative 1, which is 3, and 3/15. Now you have a fraction equals a fraction. What I would do is multiply, cross multiply. 3 times 2 is 6 square roots of t, and that has to equal 1 times 15. And then if I divide by 6, I get 15/6, but I'd reduce that down to divide by 3, 5/2. And then we're just going to square both sides. So the missing value, or the spot at which the slope of the tangent line is equal to the slope of the secant line, is 25 for us. Guarantee you, you're going to see a mean value theorem like that come up. Okay, let's look at this one. This one is another one that kids get, and then algebraically they kind of freeze. So, particle motion. Particle moves along an x-axis so that time is greater than 0. Its position is given by this function. What is the time at which the velocity of the particle is 0? What would you do? Perfect. Take the derivative and set it equal to 0. So, you can tell that this is a special kind of problem because of the way that I have e to the minus t times sine of t. If I'm taking the derivative of that, what rule do we have to use? Product rule. Okay? And a quick review of the product rule: derivative of the first plus the second times the first times the derivative of the second. And you can do side work if you want, or you can, hopefully you can do it now in your head. Let's take the derivative of the first. My first function is 12 e to the negative t. So the derivative of 12e to the negative 2t is exactly itself, except for there's a chain rule here, because if I take the derivative of the exponent, I'll have a negative 1. But instead of timesing by a negative 1 and back, we're just going to put a negative out in front. So that's the derivative of the first part. And then we're going to multiply by the original second plus the original first times the derivative of the second. Derivative of sine, cosine. So there's the product rule. And then when is means equal. When is the derivative equal to 0? Now what I've seen in the past is students can do the calculus. It's the algebra that they get stuck with. And I completely understand why. How would you go about solving this? Perfect. Factor out a 12e to the negative t. And you could even factor out a negative if you want. It doesn't really matter. But if I factor out this piece, I've got the negative sign plus cosine. And now I have the zero product property. Each piece is equal to its own zero. So the first part is equal to 0, and the second part. And then it's really just pre-calc. This one's interesting. If I divide by 12, I end up with 0. If I take the natural log of both sides, get rid of the e, I end up with negative t equals ln of 0. What is the natural log of 0? Does not exist. And that's where, if you do a quick glance at the graph of e to the x, or excuse me, ln of x, it will never hit 0. And that's the part that gets kids confused. What does that mean? That means that this part is not going to give us our answer. It's going to produce a result that's extraneous. So now I have to solve this, which is another challenge. I actually got to a point here, and I remember when I first came across this, I went to Ms. Hires, and like, how do I do this without a calculator? How do I teach kids to do it without a calculator? And she very wisely said, add sign. And then I was like, okay, well now how do I tell kids to do that? And she said, think of the unit circle. Where do sine and cosine equal the same value? Pi over 4, 45 degrees. They're both square root of 2 over 2. So they are testing some very interesting concepts here. There's your answer. We just reviewed Algebra 1, Pre-Calculus, and Calculus all in one problem. All right. No, I didn't know I put those in there. Okay, well, did I put these in here? I don't think I put these ones in here because these are all calculator. All of these you should show no work for. It's grab your calculator and do the work. So let's grab our calculator here quick, and we're going to get through as many as we can in the next couple of minutes. I think this afternoon I might just show you how to do this later on. So those of you on Zoom, you can come back at 12:55 and we'll go through it. But what I want to do is go to y equals and plug in your first answer here. Plug in the equation. Notice how I didn't even read the question yet. I knew it's calculator. So a particle moves along a straight line with the velocity given at this equation whenever time is greater than 0. What is the acceleration at 4? Okay, what I want you to do is once you have that in y equals, you could find this on a graph. You actually really don't need to plug it into y equals, but I want to make sure you guys understand how to do that. Okay. So what is the acceleration at time 4? I have the velocity and I want the acceleration. What do they want me to do? Or what do we need to do? Find the derivative. Okay? So this is logged in as y equal, or y1. Go to a blank screen. Go to math. And this time, instead of option 9, we want the derivative, which is option 8. We haven't done this one in a long time. Now we are doing things in terms of x, so we should have d dx. And you could type the equation in here, but we typed it into y1, so remember the vars button. Go over to y vars, select option 1 for y1. And then I want to figure out what is the derivative at 4. Hit enter. There you go, you're done. Super quick, right? Now here's what I don't want you to do. Don't try to do this by hand. You could do this by hand, but what does that do? It wastes a ton of time. And your answer, right there, C. Okay? All right, part B. This might be our last one, or part B, number 5. The acceleration of a particle moving along an x-axis is given by the equation for a of t between 0 and 8. At what value is the particle's velocity decreasing rapidly, the most rapidly? So go to y equals, this one we're going to produce a graph. And you should make sure that your calculator is in radian mode because we're dealing with the trig function. And anytime in calculus, it will always be in radians. When you go back to pre-calc. So that's the nice thing about calculus, is just always keep it in radians. All right, so I typed that into my equation. Notice it says t goes from 0 to 8. What I'm going to do is just fix my window from 0 to 8 because that's the x values. I don't know if the y values are good enough, but that's fine. So window 0 to 8 for your x's. Hit graph. And here's the connection. This is the graph of acceleration. When is velocity decreasing the most rapidly? This is the graph of the slopes of velocity. The rates, this graph is the rates of velocity. So when is it the lowest? What are we going to do? Find the minimum. This is the graph of the rates of velocity, its acceleration, so go to minimum. And then you just want to find that lowest, when is it decreasing the most? It's the lowest value. So I'll do a left bound, right bound. And 1.4199, so that should round to 1.412, which is B. All right, we don't have time for 6. Maybe I'll just do that one right away this afternoon. And what you should do then today is try the calculator multiple choice. And your goal, to be honest, is just to show very little work for the calculator, still knowing that you get it right. Okay? And then just as a reminder, the thought is you should spend about 55 minutes or whatever the directions say for timeline. Don't spend 2 hours trying to figure out one problem, right? That's not the best use of our time. If that's the case, skip that problem and move on. Because we know that we're not going to get 100% on all of this. And it's okay to do that. It's sometimes hard to grasp that concept